Okay, in this unit, chemical reactions, we're going to be studying 5 types of reactions: synthesis, decomposition, combustion, single displacement, and double displacement. A quick review. Clues that a chemical reaction has taken place or a chemical change has taken place. You see a color change. Heat or light is given off. A gas forms. You might know this because you see bubbles in a liquid, or you notice a change in odor. The fourth clue is a precipitate forms. This is a new solid that forms when 2 liquid solutions are mixed. Okay. So let's say you mix 2 test tubes worth of liquids, and you see a solid starting to fall out to the bottom of the one test tube that you mix them into. Okay, so the kinetic molecular theory, KMT, states that all particles are in constant random motion. Doesn't matter if they're solids, liquids, or gases. So this is called kinetic because kinetic means moving. This kinetic energy is lowest for the solids and highest for gases. So the amount of energy particles have as solids is less than the energy they have as in their gas state. If particles collide with correct orientation and sufficient energy, a chemical reaction will take place. In a reaction, the atoms of all of the reactants rearrange to form new compounds that we call the products. Okay, law of conservation of mass. Experimental evidence shows us the total mass of reactants is equal to the total mass of the products. So if you do an experiment in an Erlenmeyer flask and you stopper it so no materials can leave or enter, and you do your reaction inside of it and take the mass before and after, then you will see that the mass does not change. This means that no new materials added or removed. Atoms are just getting rearranged. Therefore, to accurately represent this information on paper, we need to balance chemical reactions. Each atom in the periodic table has a specific mass associated with it. So that means that we need the same number of each atom on both sides of the reaction. So that's where the balancing of chemical reactions comes into play. Because the law of conservation of mass, there's a conservation of mass. There's no added or removed mass from a closed reaction. And this is why we balance chemical reactions. So I encourage you to practice balancing, but there's a few things you have to remember. You cannot change a formula. For a compound. So H2O, water. This number is called a subscript. And it will stay in the chemical formula. You don't change it. The only thing you're allowed to do when you're balancing is multiplying with coefficients. And a coefficient is a number that you place in front, and it will multiply all of the atoms following it, directly following it. So here, this 2 out front will multiply both the hydrogen and the oxygen. So the coefficient goes in front of an element or a molecule, and it will multiply all of the atoms following it. So we would have 4 hydrogens and 2 oxygens. So this is the only thing you're allowed to do when you're balancing chemical equations. If we have something like this, so you've got a compound that contains a polyatomic ion, and then you end up putting a coefficient in front of it to balance. Then you multiply the chromium by 2. There's already 2 there, so in total you've got 4 chromiums. And now you've got 3 carbonates already in your compound, and that's indicated by this 3 here. So now you're going to have 2 times 3. So you either can write this as 6 carbonates, so 2 times 3 is 6 carbonates, or 6 carbons and 18 oxygens. You could do the 6 carbonates and then break that down. If your carbonate decomposes during your reaction, you don't have carbonate on the right, or you've got 2 times 3 times 1, so 2 times 3 times 1 is 6, so 6 carbons. We've got 3 times 3 oxygens, that's 9, times the 2 is 18 oxygens. So you figure out which one works best for you. Okay, so balancing chemical equations. First of all, count the number of atoms of each element, both reactants and products. You can do that just by inspection, just by looking at it. If possible, leave oxygen and hydrogen till the end, because they'll probably get worked out by themselves. If you have a polyatomic ion, that's what PAI is short for, polyatomic ion, like carbonate, on the reactants and the product side, treat it as one entity to simplify your work. So if it doesn't change, treat it like it's one entity and balance that. It just simplifies your life. And multiply the entities, the compounds and elements, by the appropriate coefficients to balance. So an example here is we have hydrogen gas plus oxygen gas making water vapor. So this is happening at a high temperature because we're making water vapor. So we need to balance this. So we have currently 2 hydrogens on the left. We have 2 hydrogens on the right, so technically that's balanced. Then we have 2 oxygens on the left of the arrow, and we have only 1 hydrogen on the right. So we have to increase the number of the number of oxygens on the right-hand side. To do that, we need to multiply by a coefficient. So we're going to multiply by 2, so that we now have 2 oxygens to balance this 2 oxygens. But because we changed our hydrogens, we now have to go back, balance our hydrogens. So now, because there's 2 times 2, 4 hydrogens over here, we need to make this 4 hydrogens over here, so we put a coefficient of 2, so we multiply 2 times 2 to give us 4. Alright, that was a straightforward one, so let's try copper solid plus sulfuric acid producing copper sulfate and water. And sulfur dioxide gas. So that's liquid water, and that's copper 2 sulfate is soluble. Okay. So here we do have a polyatomic ion on the left, and we do have it on the right, but it also decomposed. So let's start with something that's not oxygen or hydrogen, so we can either go for the sulfur in sulfate or the copper. Copper, there's one on the left, there's one on the right. Sulfur, there's one on the left, because it's a 1 subscript. There's one here, and there's one here. So we will need 2 sulfurs on the left, because there's a total of 2 sulfurs on the right. So we're going to put a coefficient of 2 in front of sulfuric acid. So now we have 2 sulfurs on the left, 2 times 1, we have 2 here and here. Okay, so now let's look at oxygen. We've got 2 times 4, so 8 oxygens on the left, 4 here, 1 here, and 2 here. So we've got a total of 7 on the right. So somehow we have to multiply something on the right to make that total 8. If we multiply, if you go back here and look at the hydrogens, 2 times 2 H's is 4. So we know we have to put a 2 in front of H2 to make 4 hydrogens, and that, I believe, has fixed our oxygens. So we've got 2 times 2 hydrogens, 2 times 2 hydrogens. We've got 8 total oxygens on the left. Now we have 4, 2, and 2. So we have a total of 8 oxygens on the left and 8 oxygens on the right, and our copper is still 1 and 1. Sulfur is 2 and 2. So this reaction is balanced. So let's do another one. One more example. Okay. Calcium hydroxide. Oops. Let's do that in black. Calcium hydroxide solution plus phosphoric acid produces calcium phosphate plus water. Clear that up. That's a 4. Okay, so start with something that's not oxygen and not hydrogen. So let's start with calcium. We have 1 calcium here. We have 3 here. So we know we will probably need to put at least 1, 3 over here. So now we have our calciums balanced. So now let's look at the phosphate, the PO4. We have a polyatomic ion that is on both sides. There's no other form of phosphorus on the right. So we're going to balance PO4 as its one entity. So over here we have 1, over here we have 2. So we will need to put a 2 in front of phosphoric acid. So now we have 2 phosphates and 2 phosphates. So calcium and phosphate are now balanced. That leaves us with the rest of the hydrogens and oxygens. So now you no longer count these oxygens. They're taken care of. You don't count these oxygens. They're taken care of. So here we have 2 times 3 hydrogens, and we have 3 times 2 hydroxides. H and OH come together to make H2O. So if we have 6 OHs and 6 H's, we make 6 H2Os. So we have 3 times 2, 6 oxygens, 12 H's, 2 times 3 is 6, 3 times 2 is 6, 6 plus 6 is 12. This equation is now balanced. There are many practice sheets for balancing chemical equations.